Okay. Figured this might be a better way to do this. More efficient. And if I go too fast, you can always rewind a part and keep going over it. And if you still can't get it, you can just DM me on that specific part and on that specific minute and second part. So I figure this might be a little bit faster than just writing, copy, pasting notes and all that stuff. All right, so here we are. picoCTF, medium binary exploitation, buffer overflow 2. And here, let me restart the instance. All right, and so as you and I both are wanting to do, we want to just look at the binary. So I'm just going to capture the binary and we're going to leave the source code out of it. All right, so I've already placed the binary inside of buffer overflow 2 in my Pico folder. Here's the vulnerable file here. And I've created my own flag.txt and it just says hooray, like that. All right, so now let's see what we got here. Here's my files. The first thing I'm going to do is I'm going to check security on the binary. All right, and it shows us this information here, which once we get heavy into rock chains and other things like that, I'm not there yet, but once I get there, I'll be doing the check sec and really absorbing what it's telling me. But as of right now, we'll just continue on with the little session here. The first thing that I want to do is take a good look at some of the things with object dump. All right. Yeah, I'm looking for important functions. So here's probably one of the most important functions is main here. And I scroll for main and I'm looking at a lot of the other functions inside main. So here we see a very important function called vuln. Okay, and in the picoCTF realm, that's always like, hey, this is where you'll do your attack at. So here's that function vuln. And looking through, all right, we can definitely see this gets well known to have vulnerability. And so it looks like that's where we'll be attacking. All right, scrolling through to, all right, and there is the famous win function. Looks like the win function is going to be our target. And so I'm going to go ahead and take the address of the win function and note it for future use. So target, and this may change, but for now, I at least want to note it. And one thing I want to do is kind of go through the win function. And what I want to take note of specifically are any compares. Any of the compares are usually like a, aha, I need to get through this compare to get to the goal that I need. And so as we're looking through, okay, we can see a compare here. Looks like just compare 0 with this location on the stack. And then not equal, jump to 62, which is actually 92 Foxtrot 8, which is here. Okay, gotcha. So if this compare fails, we're going to do a bunch of stuff right here. Okay, and then we're going to exit. Oh, okay, gotcha. So it looks like it may need to get past this compare and skip all this code here, possibly. I also take note of the printfs. These printfs, it's usually like, hey, open the file where the flag exists and then print that flag out. And so this printf, it could be, hey, get out of here, or here's what the flag file says. Because it looks like, yeah, we have an F open up here. And so here it's probably, it could be opening the flag file. All right, so continuing onward. So let's say we get past this possible flag. Let's see, an F gets, which is fine. Here's another comparison. This comparison looks very unique because it's cafe food. It's readable. It's very interesting. And then right below it, it says food. So right off the bat, I'm thinking, okay, uh, these look very interesting as far as comparisons go. And they're also comparing EBP plus 8 in EBP plus Charlie. As we've seen with ASM3 and picoCTF, whenever you have parameters to a function, they will show up at these locations on the stack. And so we know that, okay, this when function is coming in hot and it's going to check two parameters. And if those parameters is going to compare to being cafe food or food, and then it's going to do some things. So let's continue reading through here. All right, if it doesn't, so if cafe food is not the thing, it'll go to 93.2 foxtrot, which is all the way down here. And that's a no-op. And a no-op is just don't do anything. So really that's just kind of a landing spot. And then basically just leaving. Okay, and then yeah, leave and return. And then the same looks like for this one. It says, hey, and if the food 332, which is the no op location as well, and a leave return. But then let's say these comparisons do equal. And so now let's see what happens. It looks like you're adding something to the stack, or at least adding space to the stack, loading an address to EAX, pushing EAX onto the stack, and then calling printf. Okay. Because this is so much more unique, in my opinion, than this stuff up here and just a simple compare zero, I feel like if we have the win function and the win function comes in with these two parameters set to cafe food and food, feels like to me that this printf is going to be the one that gets called to give us the flag. And so that's my hypothesis. So I'm going to make a note of this thing and this thing. All right, so all right, so now the way I see it now, I believe this is the target with the two parameters. And so now we're going to enter into the program and start tinkering away at it. All right, so first thing I'm going to do is I'm going to run the thing. All right, it says please enter your string. Okay, and it prints it back at me. Let's go way off to the right. Segmentation fault. That's a great sign. That means this can indeed be overflow. All right, and so now we'll go ahead and jump right into GDB. All right, debug info, yes or no. Doesn't matter to me, yes, no, doesn't, I don't care. All right, and so now I'm gonna disassemble main. All right, this is what main looks like. I'm gonna go ahead and put a breakpoint at main. Then I'm gonna define, so I know that I've shown you, there we go. I've shown you my version of next instruction, which I defined as in X instead of in I. And what that definition says is it says down here, show me 50 things on the RSP, and then show me the next 8 instructions of the RIP, and then do next instruction. For this specific one, I've tried that before and it doesn't work, and it doesn't work because it's all 32-bit. And so what I did was I defined a different one, and this different one is going to be 32-bit specific. So let's just call it NXE. So define NXE, and then we're going to go X, and I'm going to say 100 words in hexadecimal ESP, and then I'm going to X 8I for the EIP, and then I'm going to next instruction, and then end. All right, so now I'm going to run the program. It should break at the very start of main. Okay, it did. And then I'm going to do my little NXE. Okay, so now we can see, and kind of scope out the stack as we go along. And so as we're going through, you see what's coming? You see this push 0? I want to expect that zeros are going to show up here. So if we keep going, okay, it just happened. Now I see a push 2. All right, and 2 is the least significant bit. So I expect here we're going to see a 2 pop up right here, and all these zeros get pushed to the right over here. But let's see if I'm right. That's correct. So now we have a push 0 coming up, and I expect this 2 to be over here, these zeros to be over here, and new zeros to be over here. Let's see. All right, that did exactly as I suspected. And so now we're getting a feel of how this stack moves through the program for different push, pop, pull, all that stuff. And so let's continue going through the program, knowing that our stack, how it moves through this GDB. All right, so here we're about to add 16 to the stack pointer. And so I feel like what that means, so whenever you subtract from the stack pointer, it actually grows the stack because the stack grows downward. And so what I think we're about to see with adding 16, we have 16 here. This whole line is going to disappear, and all this line is going to pop up. And so let's see if that happens. All right, that did just happen. And so now it's going to call a function with get, going to move EAX to EBP minus 0x Charlie. All right, now we're actually going to subtract 4 from the stack. So the stack will move. All right, the stack did just move. And then it's going to, looks like it's going to push, push, push. So it's going to push 3 things onto the stack here. And you'll see the 493 alpha foxtrot start going bop, bop, which it did just that. And we see something very interesting. We see 3 echo 8 being pushed onto the stack 3 times. Weird. I don't know. So we'll keep on going through. We'll just make a mental note of that. All right, we're adding 16 to the stack. So this hop is going to disappear again, and everything's going to move up. All right, and then we're going to subtract Charlie. So some things are going to show up on our stack, which are the exact same things that we just saw, a lot of them. Yeah, so 3 alpha foxtrot, 3 echo 8, 3 echo 8. All right, so then load address here, cut, push, EX. Let's keep on going. Okay, there's call to puts. There's this. Okay, so we're about to go into the vulnerable function. We're about to step in there. So I've got NI in my NXE definition. I don't want to NI into this, so I'm going to not use NXE. I'm actually going to use SI so that we can get into the vulnerable function and trace through it. Otherwise, if we keep going, it's going to pop right over to here, and we're not going to see what's happening inside the vuln. And before I do that, because I know we're going inside here, the very next instruction, 08493 delta delta, that's the return address. So I'm going to make a note of that. All Go. All right, so this is my thinking right off the bat. We're about to go into vulnerable, and we're going to see the return address 80493 Delta Delta, and we're going to want to overflow the buffer to where we get over to where that's located at the input stage, and we're going to rewrite it with this stuff. All right, so let's go ahead and SI step into bone. And instead of doing NXE right now, I want to see if my little step into instruction worked the way I wanted it to. So I'm going to do look at the stack right now without the stack moving. Okay, as I suspected, this return address after the function is now placed onto the stack. And what we're about to see is as we step through the vulnerable thing, all these mains right here, you'll see them change into vulns and will be inside the vuln function. You'll see this thing start to go all the way across and down the stack. And then we'll probably have an input somewhere where we can start doing a bunch of Ks all the way down the stack to chase this address and write over it with the address that we want. All right, so now let's do NXE. All right, as you can see, we are inside the vuln function, and we are going to continue going through it and pay attention to this address as we go through. NXE. Okay, just move to the right. Okay, just move to the right again. Now, this instruction that's coming up, this subtract 74 from the ESP, and keep in mind, this is not a true 74. This is a hexadecimal 74. So it's actually going to be 116 bytes down. We're about to see this thing fall off a cliff. And so we're going to go up. All right, so now, as you can see, we have to figure out where it went to. Okay, there it is right there. This is how far our return address fell on the stack with that subtract 74 from ESV, not subtract 74, but subtract 74. So that's 116. We could count like 8, 8, 8, 8, all the way down, it would be 116. And so now, since this is at 116 now, we need to figure out where our buffer or where our inputs actually begin. And so we're going to keep on going through. We've already seen that the gets is down here. So once this gets called, we'll see exactly where our stuff starts to happen. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So now I've placed my little Ks onto the stack somewhere. We're going to figure out where those went to. So I'm going to go ahead and do X100 WX here on the stack. There they are, right here. Okay, so when it comes to where these things are on the stack, it looks like they begin right here, right at Charlie Echo 6, and then Charlie, I don't know, I'm bad at that. All right, but here's the Ks right here. We can see that I put in, I think, 8 Ks, and so 6 Bravo, that's 1 K. 6 Bravo, that's another K. 6 Bravo, that's another, and then that's another, that's 4. And here's the other 4 coming into the side here. So there's all 8 of our Ks. And so what we're trying to do, we're trying to get down here. And so we need to figure out how many Ks does it take to get from this spot here to this spot here. And so we have to figure that out. We can actually figure out kind of in a, to me, a dumb way, because I like doing things the dumb way. So I'm going to go ahead and say, all right, well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, one. Hold on. Let me pause real quick. All right. So I've calculated and made sure that I calculated right. One of the funny things about me is I took one of the hardest classes at the University of Memphis, which was Province Stats Calculus based. And we're going over like gamma distributions and all sorts of stupid shit. And during the exams, I was still doing 8 plus 6 on my fingers. My other classmates were like, "Why are you here?" And I'm like, "Don't worry about it." And so when it comes to these things right here, I try to make sure that the count is correct. So yes, here are our Ks, 4 of them here. Here's the other 4 here. We need to calculate how many Ks we need to put onto the stat to reach our address right here. And so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 batches of Ks to get there. So 28. And these batches are in groups of 4. And so I'm going to say 28 decimal here, 28 times 4. So we need exactly 112 Ks to reach this address. All right, so Ks times 112. And to check, we can actually do this. Actually, let me go ahead and show it to you. There we go. All right, I have 112 Ks right here. I'm going to restart this program. LXC, NXC, sorry. Da, 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 da. All right, stepping into Vol. Keep going. All right, here comes the vulnerable gets. I'm going to paste the 112 Ks here. Now I'm going to take a peek at the stack. So, all right, here they are. It started there exactly how it did last time. Here's all my 100 Ks, and then boom, they stop right here. But here's something very interesting. Our return address has changed. The reason that our return address has changed is that when you're dealing with C programs, they have a null byte at the end, a terminating 0 at the end. And whenever you put something into the keyboard for a C program's input, you always need to realize that the very end of it is going to be 0, 0. And to, well, I guess, okay, I'll go ahead and show you. So run again. There we go. All right, we're stepping into Balm, NXE, all the way to the gets. All right, here's the vulnerable, and then I'm deleting one of the Ks. And so what I expect to see is, so you saw the return address showing 0, 0 at the end. Where we saw the last 6 Bravo, you're going to see a 0, 0 where that last 6 Bravo was. And so that's what we're going to see. See, and as you can see, here it is right here. You may have thought, oh, well, I was expecting to see it actually right here. Well, little Indian, these things get put on going this way in reverse. And so that's why this terminating 0 string is right there. And then you'll ask, well, why is it that it showed up over here for the DDs and not showing up over here? The reason why it didn't show up over here is because Okay, I had to make sure I was saying the right thing. Yeah, these stacks, as they go through, they're filling up from right to left, little Indian style. And so the last K is actually this one right here, not these right here. And so that's why this zero, uh, as the last six Bravo was here in the last time we ran this program, the null terminating started here. If we did another K, then it would be 0, 0 here and 6 Bravo here. And so that's just something to realize and note about the C programming language is that anything you input is going to have a null terminating zero. So let's see here. Now that we know that, and now that we know that it's 112, let's actually put that information here. All right, I'm going to put the overflow is going to be k times 112. And what we're going to have to do is we're going to have to write a Python program, or a C program can do it as well, but we're going to use Python. And we're going to make sure that we can feed this program raw bytes because I can't feed this particular version of cap A food directly into the program by saying a whole bunch of Ks and then 0x cap A food. I can't do that. And so what I have to do is I actually have to write a Python program that says, hey, treat these as bytes and then do cafe food similar to that. So I'm going to go ahead and start drafting out my attack. And so I'm going to go ahead and say new. All right, Python. There we go. Import. I think it's all. Nope. It's from Pwn import all. There we go. I get used to C. C is something like include and then uh, standard if the header file. And so with from Pwn import, I just have to get used to Python. So the challenge, let's see here. Where are we in the challenge? Let me see. Eco, buffer. Okay, here's the challenge right here. So oh, it's actually going through WSL. So my WSL path will have to be chosen. Okay, so I believe that's mount, C, users, Kyle, OneDrive. I've got to get rid of OneDrive. I hate it with a passion. Desktop, Eco, then buffer. I don't know the way to this. Let me find out. Oh wait, I can find out which is this. Okay, just buffer overflow too then. That's easy enough. And then the actual program call. Okay, perfect. All right, and then next, I just memorized this. I don't know the specifics or the understanding of it. I just know that this is how you do this. And so it's kind of like how you see a lot of prologue for the assembly language. You always know it's going to be like, hey, here's this, push this, subtract this from the stack. That way to move EBP, all that stuff. It's never going to change. This right here never changes from many of my stuff. It may change depending on some of the stuff that we get into later on as far as rock chaining, and I'll need to understand it, but at the moment, I'll just do this every single time. All right, so here is actually the code that we're going to do. So we know for a fact that the overflow, we're going to set it as k character bytes times 112. So that's the overflow. And right now we know for a fact that the target at the moment is, where what? Oh, yeah, it's all in here. Let me just grab all this. Okay, so yeah, the target is this target here. Now, I can't just put target equals this thing over here. I have to cast it to the correct format. So it's actually P32 like that. I could also do target like this, uh, bytes. And this is how you write individual bytes, which I believe once we get to ROP chaining, we're going to need to do that quite a bit. And so it would be like this, O4 and O8. And so this target is the exact same thing as this target. And so, yeah, like I said, I believe in ROP chaining. I'm going to need to know how to do this part because we're going to get kind of surgical with it. But for this problem set in particular, we can just do, hey, target P32, blah, 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 and we're good. So now we know that we have 112 Ks to place onto this stack. And we know that our target is that win function. And that win function is at 92, 96. And so what we're going to try and do is we're going to try and change this 080493 delta delta into that 9296. And so let's see here. Oh, and this should do it actually right here. Overflow a bunch of Ks times 112 of them, and then have the target. And then we would do something like the payload would actually equal like overflow plus target. And then we will put that payload into the send signal and all that stuff. We're going to get to that, but this is kind of the general idea. The problem with this problem, though, is the parameters. We need to figure out where these parameters are going to be. And so we're going to come back to that and we're going to keep on going through the program. So, and next. Okay. There's the output there. Very cool. All right, it's about to leave back into main. I'm going to allow it to do that. Cannot access memory address. Okay, so I think it just crashed or it's about to crash. So I'm actually going to rerun the program. And instead of overflowing the buffer, what I'm going to do is I'm going to just put like 8Ks on the stack. And then I'm going to set the instruction pointer to the win function and see what happens. And so here we go. Going back to the program again. And with here, so the vuln, I'm not going to step into the vuln. I'm just going to put in my Ks, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to do the next instruction. All right, so here, as you can see, we are currently at that return address that we're wanting to, get crazy with. But I'm going to set the instruction pointer equal to the address that we want to go to, the beginning of when. All right, so now we are inside of win at the moment. If I do NXE, you're going to see all these mains turn into wins. So now we're at the very beginning of win. What our goal is to find out exactly where on the stack or what addresses on the stack that these cafe and food are comparing to. And so I'm going to keep on going through till pretty much until it gets to that comparison. Here comes the comparison. So it's add 10 to the stack. Now we're at the comparison. I want to see exactly what this thing is. So I'm going to do examine EBP plus 0x8. Okay. This address right here is what it's comparing cafe food to. So I'm going to take this. I'm just going to put it over here and make a note of it. So for cafe food, Just making a note. And then it's about to jump me over like across, like I can't even get to this comparison in the code, but I can still do the exact same thing by examining it. So I'm going to go ahead and, because there's no changes being made to it from this line to this line. So this Charlie, this EBP plus Charlie is already set somewhere. So I'm going to go ahead and examine it. Okay, so that's what the Charlie is. So I'm going to copy this. All right, so that's what we're looking at the moment. And so now I'm going to rerun the program from scratch. I'm going to step into Vol, and I'm going to go to the place of input, the input, because I know for a fact that this buffer overflow problem, it's saying, here's where you're going to input something. So I need to input my entire solution right here. And so I'm going to go ahead and 8 Ks, as we do. Next instruction, and look at the stack. Here's our 8 Ks here. Here's the return address here that we know. We want to look for this and this, because this is the only point at which we can actually input things into the program, actually manipulate the program. And so these need to exist right now. And we need to override it with our solution. And so we need to search for 996 Charlie, and we need to search for 1400. And so here's our return address here. Here's a bunch of foxtrots. Here's 996 Charlie, and here's 1400. So when we create our solution, not only do we need to do 112 Ks and then our address, but then we need to do like 4 more somethings to get to these addresses. And then we need to put cafe food and food into these 2 addresses. And so we know that we need a skip. So skip equals, could skip, it says FFFF or whatever, so we could skip like this. K times, it's like 4 is fine. All right. Honestly, though, I don't know whether or not these F's are going to be checked anywhere. So I kind of want to leave these F's alone. I want to make as few changes to the state of this program as possible because it's unpredictable at this point. And so what I'm going to actually do is for my skip, I'm actually going to go, let's just say, call it clone. P32 1, 2, 3, 4. All right, there we go. So I'm cloning that location there. I've already done this problem set, and I know that I could do 4Ks and be just fine. But I'm gonna do this because I want to personally get into a habit of manipulating the program as little as possible for it to do as much as possible for me. All right, so anyway, we have our clone. We have our param1, and param1 equals, oh, we've already identified where it is on the stack. All we need to do now is set. So I'm going to set this thing, P32. Whoop. All right, so I'm setting the parameter 1 there, and I'm going to set the parameter 2, just like it, P32. Oh, there we go. All right, and then the payload, we're going to set it equal to, we got our Ks, followed by our target address, followed by the clone, leave things as much as well enough alone, and then the parameter 1, and then the parameter 2. There we go. All right, perfect. So this is what the solution, basically the solution. Let me go into desktop, CTF, overflow. Yeah, I want the solution to be inside the same directory where the program and the flag is. So here's my solution. Right off the this is pretty much it. Now we just have to figure out a way to have this Python program, and this is what you could just call the epilogue, is determining, how we're going to have this thing sent through. Let's see here. Let's go ahead and exit out of that, exit off of that, exit off of that. Go away. Go away as well. All right. I know it's something like p dot because that's our process that we created up here. And so I know it's something like p dot send, and I want to say it's like send line after is the thing. Um, okay, yes, okay, that verifies it's a function here. Oh, that's right. I have to figure out what the string is. Oh, there we go. Okay. So you see how it says, please enter your string colon, and then it zips your input down to the next line. There we go. I'm sending my payload to the next line. So here's the difference. You can do p dot send after, and that's if this little cursor, if it stayed up here. If that cursor stays up here, then that means that it's similar to VB script. VB script, you can do like a write or a write line. And so this is saying, hey, send after or a send line after. And so keep note, like if you're doing these things and something isn't working, check for that just in case. All right, now we need to print out the result. And this, let's see here, I believe it's p dot response. And then I want to say decode that response. And this is what messed me up this past few days. UTF-8. And then as far as errors go, I like to replace, I like to see them. So replace. Okay, so we're saving here. And now we're going to test it out. There we go. There. All right, have our flag. Yep, should say hooray. We have our solution. Is it the same one you're looking at? Yes, it is. And then when we have our vuln, okay, so I'm going to go ahead and run this, hope for the best. And P is not defined. Very simple mistake that I just made. Let's see what it is. Okay, figured it out. So yeah, the really dumb error that I just made was using p dot process. Now you have to declare p as a variable first, so it's p equal process. Boom. It you don't have to put in cal here. Doing elf equals context binary blah blah blah. It just Python assumes that this right here is what you mean. And so another thing that I got wrong was this line. Again, it's me not really truly understanding what's going on with Python here. And so I need to do a lot more studying. But what this should be is it should be printing. Let's see here. Got a little cheat sheet here because it's a mess of crap here. So p dot receive all and then decode that as UTF-8. Okay, there we go. and replace. Oh, it's when you encounter errors equals replace. And what you can do instead of replace, you can say ignore if you want to. I like to do replace for now because I'm new. Replace, what it does is shows you those little diamond question marks in it when it can't uh, decode something. All right, so now this should work. Let's see. Okay, running the program. All right, very simple mistake, not a big deal. And it is at the end here. So just a little syntax error. Boom, there we go. All right, and so that's the flag. And those little diamond things with the question marks, that's what you're seeing right there. And so if I didn't say replace and I said ignore, you wouldn't see those. But this is actually working now, and that's the solution. And as far as doing the solution online for Pico, uh, all you'll change is pretty much all of this stuff. And so I'll comment all that out and get rid of that. All right. Instead of P equaling all that stuff, we're going to do P equals, and then it's some kind of remote solution. Let me see if I actually have it. SS, boom. Yeah. Okay, I figured it out. All right, so here's Pico here. Here's the little net capped into Saturn, blah, 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 with the port number here. So we're going to take that information and there we go. I'm going to put the port number into here and this right here. There we go, much better. All right, and then hope for the best here. It should work. I do have the instance is currently running. Always want to check to make sure that thing's still running before you try this. You do have to run it from that location. Perfect. And so as you can see, here's their flag on their server. And so actually, I kind of like this a whole lot better than all this crap. A little bit not as messy. But this is the best way to do it as far as really brute forcing it, as the server is called, brute force dummies. So anyway, this is how I did this problem set.